Hey guys, welcome back to CCL Biology, the channel for easy to understand biology lessons. If you are a high school student who's looking for some extra help in your general or AP biology class, or if you're a college student who's in that introductory biology course, this is the place for you. I am your friendly bio nerd. Thank you so much for tuning in to my channel. In this video, I'm going to be talking about molecules and compounds. So if you want to get a better understanding of molecules and compounds, then stay tuned. While you're here, don't forget to leave a thumbs up in the comments below if you find this video to be helpful. And if you want more easy to understand biology lessons, then be sure to subscribe to my channel and click the bell to be notified about new videos that go up every week. Okay, as I said, we're going to be talking about molecules and molecular compounds in this video. Now, I do talk about molecules, what they are, and how they're formed in my video about covalent bonds. So please be sure to check that video out as well. I will post that link in the description box below. But just to define molecules and compounds quickly and kind of compare them against each other, molecules are two or more atoms that are bonded together by a covalent bond. Whereas a compound, well, it's also a group of atoms, two or more atoms, that are bonded together by a chemical bond. The difference is the atoms are non-identical, and that bond can be either covalent or ionic. So since I'm talking about covalent bonds in this video, I'm going to focus specifically on molecular compounds, that is, compounds that are formed by covalent bonds. Now, molecules and molecular compounds bond by sharing their valence electrons, and I also cover that in that covalent bonds video. But just because there's sharing going on doesn't mean it's all lovey-dovey over here. And what I mean by that is the sharing is not always equal across the atoms. And this is because of a little something called electronegativity. Now, not going to lie, electronegativity is a pretty big deal in the biology world. And if you are in AP biology especially, you're likely going to run across this word a lot. But I'm going to break it down for you so that it's easier to understand. Electronegativity is the degree of attraction that one atom has for the shared electrons in a covalent bond. All right, let's break that down. So this is what we know. We know that covalent bonds cause electrons to be shared between two atoms. So if we see here, we're looking at the representation of two atoms. You see the plus sign, that's representing the protons or the positive charge of the nucleus because of the protons. And then you see the circles here, that's representing electron shells. And these two green circles are representing two valence electrons. And as you can see, the circles, the electron shells are kind of joined together or crisscrossed here, which is showing that they have bonded together, and the electrons that previously belonged to each one of the electron shells individually are now coming together and they're being shared between the two atoms. So we know this much. But if the two atoms are two different kinds of atoms, like an oxygen and a hydrogen or something like that, then one of those atoms may actually pull those electrons that are being shared more closely to its own nucleus than the other atom is pulling. So this may still be kind of abstract, so let's bring it home a little bit. I like to think about this like tug of war. So you've got both teams that have their hands on the rope, so they're sharing that rope. But one team eventually pulls its share of the rope harder or closer to its side than the other team is pulling. So you could say that that team has a greater degree of attraction for that rope. So it's the same when we're talking about electronegativity. Both of the atoms essentially have their hands on that valence electron, or however many valence electrons they're sharing. They both have their hands on it, but one atom is pulling its share of the electrons closer to its nucleus than the other atom is pulling. And that atom that's pulling it more closely has a greater degree of attraction for those electrons that are being shared. So that's kind of what electronegativity is. Now, let's talk about why that sharing is sometimes unequal. Well, some atoms want electrons more than others. They just have a greater degree of attraction to it. And so the more an atom naturally wants an electron, the more electronegative it's going to be when it's covalently bonded to another atom. and the more electronegative it is, then the more strongly it's going to pull the electrons that it's sharing in that covalent bond with another atom. Now, the electronegativity of every element is actually quantized. There's a number to measure it, and you should not be required to memorize any of those numbers. But a good rule of thumb, if you're looking at the periodic table, is to know that electronegativity is going to increase as you go up the periodic table. So if I'm going from here, this row 7 up to row 1, it's going to increase, and it also increases to the right. So as you go up and as you go right, the atoms tend to become more and more electronegative. So typically, the closer an atom is to filling its electron shell, its valence electron shell, so the closer it is to getting to 8 electrons in its valence shell, typically the more electronegative it's going to be, the more it wants an electron to just fill up that shell so that it can become complete and stable and not have to do a whole lot of reacting. So let's grab 2 atoms here, oxygen and hydrogen. Actually, it's going to be 3 atoms because I have 2 hydrogens, 1 oxygen. Don't judge me for this crazy looking sick Mickey Mouse picture. I'm not the best artist. But I've got this molecule with these 2 hydrogens and the oxygen, which by the way is H2O, which is water. So in this picture, you have your electrons that are colored red and orange. And the reason I have 2 different colors is to show the electrons that are being shared versus the electrons that are not being shared. So here in the oxygen atom, I have these 2 electrons in the first shell, electron shell, that aren't being shared. I've got 4 in the valence shell that are not being shared. And then I have electron number 5 and electron number 6 of that oxygen atom. And those electrons are being shared. So that's why I have them orange. They're each being shared with the hydrogen atom. Okay? And then the hydrogen atom, each hydrogen atom is sharing its own 1 valence electron. So that's why I've got this electron here in orange and this electron in orange as well. So they're sharing, but oxygen is more electronegative than hydrogen is, meaning it's more attracted to these shared electrons than the hydrogen is. So it's actually going to pull these, I don't know what kind of shape that is, but it's going to pull those hydrogen ions more closely to its own nucleus. The same here. It has a greater hold on those shared electrons than either of the hydrogens have. So this kind of covalent bond, when you have that unequal sharing of electrons, is called a polar covalent bond. Now, a lot of times you'll see this little doodle here, and I'm going to do it in red because it's typically the color that you'll see it. You'll see this little sign here. Kind of looks like a backwards S or a clumsily drawn D or something. So this is the Greek letter delta, and the negative side, so you put a negative sign next to the more electronegative side. So here, this oxygen is more electronegative, so it's going to make this whole side of the molecule more negative. So I'm going to put a negative sign next to that delta there. And then the positive sign goes toward the less electronegative side, which in this case is going to be the side with the hydrogen. So I'm going to put a plus sign by that delta there. Now, what about a covalent bond between 2, let's say, hydrogen atoms? Let's take a look at that. So I've got that here. You see the 2 hydrogens and the little line in between that's showing that there's a covalent bond. Now, since these 2 atoms are identical, they're exactly the same, their electronegativity is also identical. So each atom is pulling the electrons that it's sharing just as strongly as the other one. So there's an equal sharing. Now, if we were to take this back to our tug of war example, this would be like a standoff, between the 2 people or teams who are pulling. So this type of covalent bond where you have equal sharing between 2 atoms is called a nonpolar covalent bond. Polar covalent bonds and nonpolar covalent bonds, again, that's another pretty big topic in the biology world. So you want to make sure that you have an understanding of that. The basis of that just comes down to the difference in electronegativity the greater the difference in electronegativity between two atoms, the more polarity there's going to be between those two atoms. So again, when we looked at the oxygen and the hydrogen example, there's a large degree of difference in electronegativity. Oxygen is way more electronegative than hydrogen, so there's a high degree of polarity, so that makes it a polar bond. Versus the two hydrogens, they are equally electronegative, so there's no difference in electronegativity, so it's going to be nonpolar. So anytime that you have a covalent bond between two identical atoms, like what we have here with hydrogen, that's by default going to be a nonpolar bond, because those atoms are always going to have, identical atoms are always going to have identical electronegativity. But you can also have a nonpolar covalent bond between two different kind of atoms if the electronegativity of those atoms is close, is similar. So for instance, carbon and hydrogen, they form a nonpolar covalent bond, even though they're two different kinds of atoms, because the electronegativity of carbon is similar to the electronegativity of hydrogen. They're close enough that both of those atoms, even though they're different in size, they have a different number of electrons, they're pulling the electrons that they're sharing to an equal degree. So it's going to be pretty similar level of electronegativity, so that's going to be a nonpolar covalent bond. Well, that is it for today's video. I hope that it was helpful for you. If so, please let me know by leaving a thumbs up in the comment section below. And if you have any questions, then definitely type them in the comment section, and I will do my best to provide you with an answer. Thank you so much again for watching CCL Biology. That is Christ-Centered Life. Thanks, God bless, and bye-bye.